We're given this messed up equation, 9x squared plus 25y squared equals 225, and we're told to sketch this thing and identify the location of the focus, or both of the foci. Solution. So if you notice that this thing has both an x squared and a y squared in it, and we are working with ellipse now, so we are going to consider the standard equation for the ellipse. That is x minus h parentheses squared over the a squared plus y minus k parentheses squared over the b squared. And remember, the a squared is the horizontal distance side to side from the center, and the b distance is the distance up and down from the center. And for an ellipse, we always set that equal to 1. This is our standard equation. Okay, so if they gave us an equation, it doesn't look anything like this, but if we can get it to look like this, we'll discover what the values are for the missing portions h, k, a, b, and we can do some sketching and find the foci. So let's see what we have. We have 9x squared plus 25y squared equals 225. So the first thing we want to do is get 1 on the right side. In order to get 1 on the right side of the equal sign, we need to divide by 225. That'll give us our 1. But if you divide the right side of the equal sign by 225, you must divide the left side by 225. So divide both sides by 225 and simplify it, see what you get. Well, 225 can be factored, fortunately. It factors as 9 times 25, so we can cancel 9, and it leaves 25 down below. We can factor out the 25, it leaves 9 down below, and of course the right side of the equal sign simplifies simply to 1. So we are left with x squared over 25 plus y squared over 9 equals the other side, which is 1. We almost have the perfect form. Let's just go ahead and fill it in. The h and k are clearly going to be 0, so this would be parenthesis h minus 0 squared. That's the same as x squared, x minus 0 squared. Over, okay, we have to write the bottom as a perfect square, and indeed it is 5 to the second power. Plus, for y squared, we write it as y minus 0 squared over 9 can be written as 3 squared equals 1. Now we just need to compare these two to identify h is equal to 0, k is equal to 0, a is equal to 5, and b is equal to 3. Okay, let's do our sketch. Let's see, here's our vertical axis and our horizontal axis, and we're going up to 1, 2, 3, down 1, 2, 3, negative 3, and then that's according to our b value. We put hk in the center, hk is here, and then we went up 3 and down 3 for our b distance. For our a distance, right and left, we go out to 5, 1, 2, 3, 4, 5, and to the left, 1, 2, 3, 4, negative 5. Okay, and we can start our sketch. You see how it's wider than it's longer. Okay, and we can see here that if we embedded our right triangle, we don't know exactly where the focus is, so I'm just going to stick it in here someplace and recognize that this distance from the center to the focus, that's called the distance C. Okay, and this is the location of our focus. We haven't exactly determined where that's at yet. And then the distance from the center up to the top, that is called the distance B. Distance B. And then the point connecting the focus to the upper edge, that distance is called A, which is also the same distance as this. That's also called A. So there's our right triangle. There's our sketch. I'm going to put a box around this because that's the sketch that I was asked to find. The last thing I have to find is the location of the two foci. One's approximately here, the other one's somewhere over here. Okay, I just don't know the location yet, so I'm going to take my embedded right triangle out and work with it. Here's the right angle. Okay, the distance B, we know the B value. The B value is 3. The distance C on the bottom, we have to figure out what that is. I'm not sure what that is. We have this location. This is the origin, 0, 0, because that's the location of the center. And then the distance A, the hypotenuse, the side opposite the right angle, that distance is given to us as 5. Okay, so, of course, we can use Pythagoras to find the missing side C. Now, why is that so important? Because you know that the focus is going to be located right over here. And we'll be able to find the ordered pair location of the focus if we can get this distance C from the origin 0, 0. Okay, so Pythagoras says that hypotenuse squared, hypotenuse is side opposite the right angle, equals leg squared plus leg squared. There it goes. Okay, so 25 equals 9 plus C squared. Turn that around, solve for C squared. You got 25 minus, is it going to be minus or not? No, it's 25 minus, yes, it's minus 9. So C squared is equal to 16. So C is equal to plus or minus the square root of 16, but just use the positive square root because this is a distance. So C is equal to 4. Now that's really important because you can go back to the graph and see the location of the focus if you know that it's 4 units right and left from the origin where the center is located. So that implies that the foci, both of them, are equal to plus or minus 4, comma, 0. So in one case it's positive 4, 0. In the other case it's the ordered pair, negative 4, 0. So we found the sketch, we found the location of the foci, both of them, and we are finished.